Hi, welcome to the continuation of part 1 of the lesson on water environment in the subject Environmental Science and Engineering. The terminologies used in this lesson include bathymetry, meaning measurement of water depth, dredging, meaning bringing up or clearing from, fauna, meaning animals of a habitat, flora, plants of a habitat, habitat, meaning natural home, reclamation, meaning attempt to make land suitable, and transpiration, meaning taking in and giving off of water by plants. A water body system may be an ecosystem. As an ecosystem, it consists of living components, non-living components, and the interrelationships between the living components and the non-living components. In a water ecosystem, a material balance exists. A balance equation in the water ecosystem may be expressed as the rate of accumulation equals inflow minus outflow plus the rate of generation minus the rate of consumption. For a closed system where there is no inflow and outflow, the rate of accumulation or the change in storage is equal to the rate of generation minus the rate of consumption. For a closed system with no reaction, the rate of accumulation equals 0. Notice that the rate of accumulation is expressed in this expression using the derivative of S with respect to T, while the change or the rate of accumulation or storage is with respect to time. Hence, the T represents time. The differential S represents a change in S representing storage or accumulation. Earlier, the general water balance equation was given. Notice that in the expression given, the right side is expressed using an operator D. Notice the right side is change in storage. The left side of the equation is still equal to the inflow minus outflow plus generation minus consumption. Notice that the precipitation may mean inflow. The groundwater flow, evaporation, and transpiration are with R at the left side of the equation. Negative. A water ecosystem may permit entry of non-living component and the flow of non-living component in the open system water body may be expressed as L equals Q times C, where L is mass flow of the material expressed in mass per unit time, and therefore can be in the units of grams per second, where grams is the unit of mass and second the unit of time. Q is discharge of the open system water body, which is expressed in volume per unit time, and so may have the unit cubic meters per second, where cubic meters is unit of volume and seconds unit of time. C in the expression L equals Q times C is concentration of the material expressed in mass per unit volume, and therefore grams per cubic meter may be the unit of the C, where grams is unit of mass and cubic meter as unit of volume. There are civil engineering works which are at interaction with water environment. These include port works, canals, river and shore improvements, lighthouses and dry docks, fixed structures for irrigation, flood protection, drainage, water supply, sewerage works, and tunneling. A civil engineering project may be involved with environmental components, and the environmental components may include the living and the non-living components and the interrelationships between the living and the non-living components.